So this will boil down to what? 4 models, right? Napa Cab, Sonoma Cab, Napa Zen, Sonoma Zen. Ignore the promotion stuff, we're going to leave that out. And I think we're going to leave out the time trend also. Are we good with this? Are we clear with this? All right, so model 1, right? For Zinfandel, let's zero everything out. For Sonoma Zinfandel, everything zeroes out. Napa 0, Cab is 0, Napa Cab is 0, Napa Score is 0, Cab Score, everything zeroes out. So our base category is Zinfandel. So beta 1 represents the effective score on the price of Sonoma Zinfandel. For Napa Zinfandel, all the Cab dummies zero out again. I'm sorry, yeah, all the Cab dummies zero out, but we have the Napa dummies. So our effect of score on Zin, we got a different intercept, but we're not really that concerned about the intercept. Our effect of score on Napa Zin is going to be beta 1 plus beta 5. Cab, let's go with Sonoma Cab. So the Napas zero out and the Cabs are going to equal 1. On our effective score on Cab is going to be beta 1 plus beta 6. And then for Napa Cab, Napa equals 1 and Cab equals 1. So our effective score on Napa Cab is going to be beta 1 plus beta 5 plus beta 6 plus beta 7. All this makes sense? Yeah, we should be relatively comfortable with this. We've been doing it for a while. So we run the regressions and we see what's going on. And here's the nice thing is that, let's ignore that for a minute, come back to it. And here's the regressions. And here's the cool thing about these regressions. Well, I can just show you. We know the slope is going to be the ratings effect. The slope is going to represent the effect of ratings on price. But the difference between these two curves, the vertical distance between those two curves, represents the Napa premium. It's how much more consumers are willing to pay for a Napa wine relative to a equivalently ranked wine from Sonoma. So the vertical distance at any point is going to represent that Napa premium. So what we need to do to figure out that Napa premium, we're going to look at two things. One, we're going to look at the slopes, and two, we're going to look at the vertical distance. And essentially, this is like a forecast, right? We're going to forecast log price at a specific ranking. One for Napa, one for Sonoma, and then we're just going to take the difference. We're going to subtract one from the other. That difference is going to be our Napa premium, if it exists. Clearly there's a Napa premium for Cab. Not so much for Zin. Any questions? So we'll do we're gonna have, excuse me, an equation log price equals beta 0 plus beta 1 score. We'll have one for Napa, and we'll have another equation, beta 0 plus beta 1 score. We'll have one for Sonoma, and we know what all the coefficients are. But we want to predict for a specific score. Remember, we want to hold quality constant. So to hold quality constant, all we do is pick a score. 85. And then this will tell us what? This will tell you what is the log price, whatever that is. The log price doesn't have much of a meaning. But what is the log price of a wine that scored 85 from Napa? And what is the log price of a wine that scored 85 from Sonoma? Now, individually, those don't have any useful interpretation, so we can't think in terms of log prices. At least I can't. But when you take the difference of these two equations, right, this is going to equal something, this is going to equal something, and that's going to equal something. When you take the difference between those two log prices, that difference will represent the percentage premium people are willing to pay for a wine from Napa over an equivalently ranked wine from Sonoma, both at 85. Clearly, there's a difference there in the cabs, which makes sense. Let's see what that difference is. Model 1, Zinfandel. There's our Zinfandels from Napa and Sonoma. And there's our constant. There's our coefficient on score. So that for a Sonoma Zinfandel, every 1 unit increase in score results in about a 3.1% increase in price. So consumers are willing to pay about 3% per score unit increase. For Napa Zin, there's our Napa dummy, that goes there. There's our Napa score interaction, that goes there. We add those, and it turns out to be pretty similar, about 3.3% for every unit increase in score. I'll address this later.
But your slopes weren't the same, so when you took that 85%, it's gonna give you the price premium for 85%, but that's not gonna, at that point, right, that point.
At that one point.
But it's not gonna be consistent through the whole.
No, it won't, it'll differ. But we had to pick up, and we have to pick 8 points. So I'm just picking, so we can change the points. And,
I just,
well, the slopes are the same though. The slope of a straight line is constant, so the slope's gonna be the same.
for the Napa, but the
For both.
Napa cab versus, the slope is the same for the Napa cab versus the Sonoma cab? It's just different by that premium, but the slopes are the same?
The slopes are different. One's 3.1 versus 3.3, but the slopes are gonna be constant throughout the entire range, so it doesn't matter where we pick the point. This isn't evaluating it at any specific point. This is the slope of a straight line. And what do we know about the slope of a straight line? It's constant, right? It's always gonna be 3.3%, it's always gonna be 3.1%, yeah.
You said, we reviewed the unit, for everyone increase in one price, there's 3% increase in score, or is it?
No, it's the other way.
Okay, so okay.
So for every 1 unit increase in score, price goes up about 3.1%. For Zin, Sonoma Zin, and for Napa Zin, it's about 3.3%. For every 1 unit increase in score, price goes up. They can charge about 3.3%. All right, let's go to cab. Here's our cab equations. cab equation. There's our cab dummy. There's our cab score interaction. We add up that. And for cab, it looks like score has a bigger effect. That is, for Sonoma Cab, for every 1 unit increase in score, the price goes up about 6.3%. So it appears that rankings are more important to cabs than they are to, at least Sonoma. Let's look at Napa Cab. That's our big fat equation there. So there's our dummy, Napa dummy. There's our cab dummy. There's our Napa Cab dummy. Because we have a Napa Cab. There's our score interaction, Napa score interaction. There's our cab score interaction. And there's our Napa Cab score interaction. Add all those up. Whoops. Well, yeah. And it's pretty similar again, about 5.6%. So it looks like ratings is more important for cabs than it is for Zins. We'll address that a little bit. Now, one of the things that we want to, any questions? One of the things we might want to control for is, kind of like what she had said earlier, the sophistication of consumers. Cab is the top seller, right? Top selling varietal. So you have a much wider audience, much wider consumer base. You have very, very sophisticated consumers and very, very unsophisticated consumers. So you've got a lot of heterogeneity amongst your consumers. Zin is not a top seller. It's not a top 5 seller, I don't think. Probably Cab, Merlot, Pinot. I looked at the numbers, but I don't remember where Zin was. Zin was low. But who does drink Zin? How would you describe a Zin consumer?
I like Zin.
What's that?
I like Zin.
What's that?
Rowdy.
Rowdy?
Rowdy.
Really?
Yeah, that's what they're known for, Zinheads. They like purple teeth and high alcohol, and the Ravens with tattoos, and they like, that's what they're known for.
All right, I love Zin.
I do, I like it too, nothing
Yeah.
wrong with that.
I'm not that rowdy, am I?
People who don't like his biggest chief complaint is too much spice.
Too much spice.
Yeah, it's not like.
But in terms of wine knowledge, how would you describe a Zin consumer?
Maybe lower knowledge because it's known, it's like a fruity wine, so it's very easy drinking.
It's more of a cult wine, I think. It's a small consumer base, and they tend to be. It's a relatively small consumer base, as we know, just relative in terms of market share. But they have their own organization, ZAP, Zinfandel Advocates. So I would actually argue the opposite, that they tend to be a much more informed group of consumers. And they probably know a lot about Zins. And we know that, at least from the graph, there was no Napa versus Sonoma premium. Because if you know your Zins, you know what?
There's not many Zins in Napa.
Yeah. Sonoma probably makes better Zins than Napa does. Sonoma's a capitalist. And hence there's no premium. So that makes sense. Also, if I know my Zins, I probably have some favorite brands like I do. And I may go more by brand, right, than ranking. I have my favorite brands and I buy those brands. So we might want to include brand in here. And see what happens. See what happens to the graph. Because we have the brand. We have the whole SKU. No, ratings effect. Ratings effect. Yeah, we already did all this. Napa premium. The vertical distance between those two lines was evaluated at 85, a score of 85, was about 33%. And for Zen, it was 6%, it was relatively negligible. So what does that mean, 33%? So when we took the difference of when we took this difference, it was 0.33, so consumers are willing to pay 33% more for a cab from Sonoma, from Napa, over an equivalently ranked cab from Sonoma. That's what that means. But remember, we're ignoring the fact that brand probably plays a role in a lot of this. People know brands, and we know, Opus One, and we like, what's the one you mentioned earlier? What's that?
Was it Ravenswood?
Ravenswood, yeah, you mentioned Ravenswood and some of the other stuff, so, people choose by brand, so we should probably include that. Let's go. So essentially to get the premium, I did what I said on the board. We just took the equation, and I plugged in 85, and we got 2.07. Again, doesn't mean anything, it's the log price. Plugged in 85 for Napa Zen, I got 2.8. Took the difference, and it was 0.067 or 6.7%. Did the same thing here. Plugged in 85 for score, and we could have plugged in any score, but I chose the average score, which was 85. And we got a log price of 2.9. Plugged in 85 here, we got a log price of 3.82. Took the difference, and we got that 33%.
Does it matter that one's 0.85 and the other's 85?
One is 0.85.
So you're using the decimal percentage, and then in the last two equations, you're using the full 85? Why did that change?
Does
For
Napa
your 85.
Zinfandel, it's 0.85.
Oh, that's a typo.
Okay.
Yeah, that would matter big time.
Yeah.
Could be less than, your ranking was less than 1. That's probably not a good one. Like a $2 check or something. I give you a 0.85. So Napa premium for cab. All right, so let's do this, brand versus region. So we're gonna add something called omitted variable bias, could bias our results. Are we attributing to rankings, are we attributing something to ratings that's actually a brand effect? So we wanna make sure we don't bias our results. So we're gonna add in a dummy variable for brand. Brands. There's 100 and some odd different brands in the data set. So we're gonna need that many, one fewer dummies. Right, the rule is one fewer dummy than you have categories, right? So if we got 110 brands, we need to put in 109 dummies. We'll have to generate those. Because brands aren't like month, we can't use IDOT. It's gonna be brutal. So there's our model, and again, it's gonna boil down to the same thing. Except there's gonna be branding. A whole bunch of dummies for brand. But this is the same slide as the previous one. Here's our regression results, let's not worry about that just yet. But here is the picture of the regression results. Again, you get similar results for Zen. Including brand didn't make that much of a difference for Zen. But look at that vertical distance now for cabs. It's a lot bigger. How much bigger? It's about 100%. Or the premium now is about 100%. So let's go to the same calculations. No, well, there it is there. It's 114%, my mistake. So what does that mean? It means that consumers are willing to pay twice as much, more than twice as much, for a cab from Napa over an equivalently ranked cab from Sonoma. That's the value of a brand, of a regional brand. That's why Sonoma instituted a few years back the policy, the law that said every bottle of wine has to now say Sonoma County.
They're gonna buy 33.9% more, or
No.
they're gonna pay?
They're gonna pay 33.9%. And virtually no, not much of a premium for Zin. So not much changed. We did see the ratings effect change a bit though. In our first model, it was 3.3, 3 and 5 for cabs, and now we've got significant results here. It's kind of weird. Negative. I'm gonna be able to fix that.
So I'm missing what that brand is getting. So I understand the 33.9 is
Yeah.
that premium. And now we've added in brand that's given us 114.
Yep.
So tell me what that means. That means that brand and premium are more important by 114%?
Nope.
Okay, what's that mean?
What is?
By
what is the-
adding in
what-
brand, what's that mean?
Well, forget the adding in brand,
Okay.
let's just read the table. What is the headline of that table? What's right above model 1 and 2?
What are you talking about?
Even closer.
The Napa premium?
Napa Premium, exactly. So what we're looking at is the Napa Premium, right? And how do we define the Napa Premium? The one that you understood it, 33.9%. How did we define it?
That was the premium that people were willing to pay in Napa versus Sonoma.
For
For a cab.
Exactly, for a cab from Napa over an equivalently ranked cab from Sonoma. The Model 2 Premium has the exact same interpretation. It's the exact same, it's still a Napa Premium. The model's different, but the interpretation's exactly the same.
So people
So,
are willing to pay 114% more for the Napa cab than Sonoma.
for equivalently ranked Sonoma. Yep.
But that's when we plugged in the 85 score
At a score of 85.
and the dummy for.
And the dummies
brands.
for the brands, yeah.
So on the Zinfandel, does that mean they're not willing to pay as much on the first model, the second model?
Exactly. It's 0.2%, it's statistically insignificant. So the interpretations don't change, the coefficients change. We've got a better model now. What it means is that people are using both brand and region and score. And we're getting a more accurate measure of the individual brand, region effect, I should say. And we can look at the individual brand effects, but that wasn't the main concern of this paper. This paper, the main concern of this paper is the Napa Premium. How much more are people willing to pay for a bottle of wine from Napa over an equivalently ranked wine from Sonoma? But we gotta include the stuff that is gonna affect the purchasing decision, like brand.
And if the numbers were the same, then brand isn't.
Brand wouldn't have had any effect, exactly. The model wouldn't have changed.
And so your Napa, Cadbury, cab Sauvignon, rating effect model 1, at 5.6, that's signifying what?
That's our ratings effect. It's the stuff we talked about earlier. So we already went through those, right?
Yeah, so you're saying that based on those ratings, they're gonna pay more? Is that just for that individual, then it's not really versus, Napa or Sonoma, is it just Napa by itself? Based on the ratings score?
I'm not sure. Ratings effect measures how much ratings affect price, right?
In isolation, or as a comparative?
In isolation of what?
Like Napa cab just by itself, or it's that 5.6 is saying that?
It's saying that for a Napa cab, which it says, people are willing to pay 5.6 more for every unit increase in the rating.
Just for the Napa cab, not relative to the Sonoma cab?
Correct. The Sonoma cab's got its own coefficient.
So those are all just by themselves individually?
Yeah,
Okay.
that's why they're separate.
So for a higher rating, Model 2 for a cab, they'll pay less.
It sounds like it, but it's probably statistically insignificant. Yeah, that's why I said it's kind of weird. Yeah. And you can kind of see that from, yeah, sloping down. Yeah. Sloping down a little bit. So the big wow is, holy cow! Yeah. Napa is killing us in reputation. By us means, Now, one more thing question I had was, what if these effects differ across different ranges? That is, if we expect the same result from a low price cab as we would from a low ranked cab, as we would from a high ranked cab.
Yeah.
I don't know, but we want to test that because this kind of tells us there's 100% premium, and that's a good thing. I'm sure people from Napa are happy. But to get a better look, we might want to just see kind of the nature of that Napa premium. Because if you're, let's go back to the sophisticated versus novice wine consumer. And again, notice we always go back to consumer behavior. That's what we're trying to measure. That's what brand loyalty is, consumer behavior. If you're a sophisticated, if you know a little bit about wine, well, let's go back. Let's start with the novice. If I know nothing about wine, what do I know? I know Napa. Exactly. If I have absolutely no knowledge about wine, and I want to try to impress some chick I'm taking out a date in a restaurant, then I'll order the Napa Cab. What brand? I don't know because I don't know anything about brands. But I know that much about wine. And how do I know that? Maybe I went to Disneyland. And Disneyland has what? Don't they have Napa World? California World, which is a little wine country.
Yeah.
Yeah. And by the way, who financed? Who sponsored Big Chunk of it? Mondavi, yeah, Mondavi. Before you got. So I'm trying to, yeah. So if I don't know anything about wine, I know Napa makes good wine, so I'm going to order a wine there. And I know Cab. I've heard that. Just saying Cabernet Sauvignon probably makes me sound informed. But if I know about wine, I know Sonoma makes just as good a wine as Napa does. So I'm probably less reliant, if I'm a sophisticated consumer, I'm less reliant on regional differences than I am on what's a good signal of quality to me. I know the brands, right? I know that St. Francis has a good zin. I know that, I know the brand. So the effective region might differ depending on the different kinds of consumers. So I want to add something that's gonna absorb that. That's gonna represent that difference among consumers. And what I added, have we used squared terms yet? I just added a squared term. What does that mean? I added if you think of, let's go back to y equals mx plus b. We know that's the equation of a straight line. We know that. Y equals mx plus n x squared plus b is the equation. Is what? Is what kind of equation? It's a quadratic equation, right? And a quadratic equation isn't a straight line. It's a what? It's a parabola. It's going to be a bowl, a mound or a bowl. What I want to see, so it's a really easy mathematical trick. What I want to see, what my hypothesis was that here's score, and here's log price, is that we get something like this, right? And if you kind of finish it off, it would be a bowl. my hypothesis was that for relatively low-priced wines, remember, I'm trying to look at consumers' purchasing decisions and signals of quality. I don't know much about wine, which means I don't read Wine Spectator. I don't know who Robert Parker is. I don't know what a good score or a bad score is. To me, 85 sounds like a good score. That's a B, right? I'm sure some of you would die for an 85 in this class. But for wine, have you ever seen one of those sandwich boards out in front of a winery that said, we scored 85? No, you don't brag about scoring an 85 on your wine. It's not a very good score. But I don't know that because I don't know anything about wine scoring. I don't read Wine Spectator, I don't know anything about that. What I do know is what? Napa. That's my signal of quality. My signal of quality is, I know Napa. I know Napa makes good wine. So I'm gonna rely very little on score, and I'm gonna rely heavily on the signal, the quality signal that I do know, which is Napa. So I would expect a big premium here. Now, as you get into more highly scored wines and more expensive wines, this is probably a different group of consumers, what you said. I know my wine, and I know that 85 is not a good score, and ranking probably is a better signal of quality to me than region. Right? I know Napa makes some bad wines just like Sonoma does. So I'm not gonna use Napa as a signal of quality as much as I will a score. So that was my hypothesis. How did I model it? I just used the 8th grade trick, quadratic function, the parabola. So I added that squared term. Why am I back to that? Boom, I added a squared term. Did I add it? Yeah. Score, the same thing. Score squared. There it is. But I had to interact it with everything else that has a score in it. So Napa score squared, and Cab score squared, and Napa Cab score squared. So once I introduced score squared, I had to interact it with everything that was interacting with score. Man, that's a mouthful. Oh, and then Paragon. All right, for Zinfandel, we got that. That's our base category. Everything zeroes out for Zin. You gotta love Zin, just for that reason alone. Here's our equation for Napa Zin. Here's our equation for Sonoma Cab. And here's our equation for Napa Cab. It's not bad.
And we're looking at score squared,
Yep.
because that's telling us the difference as you
Yep.
price change,
It's not telling us that. What it'll tell us is, we'll get to that in a bit. So now, a score square just allows the curvature. It allows the curvature.
It eliminates any of the negatives.
What's that?
It eliminates any of the negatives by squaring it.
Yeah, well, there's no negative
Yeah.
scores though. That would be awesome if there was negative scores. Yeah.
What is a really good wine score?
Usually anything over 90, I mean, you guys know more wine more than I do, so, yeah.
That's what Arbor missed. I'd like to sell you.
Huh?
If you don't know any better.
Yeah, I know nothing.
Bad.
Arbor Mist?
Yeah, we saw it. So people in Nebraska.
Yeah, that's what people in Nebraska do. Okay, so we'll get to the interpretations, but we know how to put the model together and we know how to do all this stuff. It's just, this is just the housekeeping, right? Can you imagine seeing this slide on the first day of class? I should start out the class.
Yeah.
It would be me and me, basically. All right, so let's, this looks like the same, to answer your question.
Square, the square.
The score squared, yeah. So, I was getting confused. We're not gonna worry about how it comes up. It's basically the derivative, but we don't wanna get into calculus and stuff like that. But to measure the ratings effect, it's going to be, for Zinfandel, it's gonna be the coefficient on score plus 2 times the coefficient on score squared times score. So you just need to write that down. But that's gonna be the syntax. It's gonna be the coefficient of score squared plus 2 times the coefficient, the coefficient of score plus 2 times the coefficient of score squared times score. All right. For CAB, here's our model, right? So we're still gonna be, to find the ratings effect, it's still gonna be the coefficient on score, which is now beta 1 plus beta 5. The coefficient on score squared, beta 8 plus beta 9, times score. So it's still the same thing, but we have different coefficients now. Yeah.
On the Zinfandel one,
Mhm.
equals beta 1 plus 2 beta 8 score.
Yeah.
So is that score supposed to have a squared on the,
No.
so where does the squared go? You just moved stuff around, haven't you, from the previous one? You just divided both sides by a score, haven't you?
Not really. I took the derivative,
Oh,
but we don't want to get into that. But we do know, we do have the same syntax. Coefficient on score plus 2 times the coefficient on score squared times score.
Do we know what that means yet?
Yeah, that's our rating spec. That's our slope at a point. For CAB, again, it's going to be coefficient on score plus 2 times the coefficient on score squared times score. So we'll get that. What's that?
I know why P0 and 3 disappeared, and I didn't,
What?
because when you take the derivative of the number, it's
Okay.
zeros.
Yeah, that's what Let's not get too much into the calculus. Okay, and then for, this is now Napa CAB, we're gonna end up with, again, it's the same thing, but it's the coefficient on score plus 2 times the coefficient on score squared times score. So it's the same pattern over and over and over. And if you're outregging into Excel, right, this is just cells. These are just cells. And again, if it's still, by allowing a nonlinear term in here, the score squared, it'll allow for this to be nonlinear, but if the true relationship is linear, it'll still keep a straight line, a relatively straight line. So we're allowing for nonlinearity. We're not forcing nonlinearity. Let's see what's going on. All right, so let's ignore that. Kind of see the picture we wanted. Notice that every time when we've changed the model, the Zin stuff hasn't really changed. It's kind of looked like that the whole time. So Zin behavior is pretty consistent throughout these models. But the Napa behavior has changed. We've got a relatively flat line here, and then it increases and goes up. And if we measure at that same point of 85, we you do the math, if we measure at that same point of 85, again, the Napa premium is 107%. So consumers, again, are willing to spend twice as much for a cab from Napa relative to an equivalently ranked cab from Sonoma. But we know that those effects are gonna be different because we saw that graph. So if we compare it to a high price and a low price, what was my high price and low price? Or my high rating and low rating? I forgot. But we've got that 107%, that was at 85, and I think this was ranked at maybe 91 or so. It was evaluated at 91. So instead of putting 85 in my regression, I put 91. And what happens to that Napa premium for cab? It virtually disappears. 4%, fairly small. Which means that these two curves are essentially going to converge, and they do converge. Which is consistent with what I thought. In other words, I thought that the people willing to pay the biggest premium for Napa wine over Sonoma wine are going to be the novice consumers, the people that don't know much about wine. People that know wine will buy based on brand, will clearly based on ranking, because they know something about the rankings. But they're not going to buy really based on regional, by region, because they know there's lots of different regions for wines. By the way, outside of Sonoma, and we think that we're this world famous winemaking region. Outside of Sonoma, people never heard of Sonoma. It's amazing how many times people have asked, Sonoma, where is that? The Nebraska people, they don't know, they know Napa, but they don't know Sonoma. It's, yeah, it's weird. They know Napa, exactly. Over here, we know Napa and Sonoma, and we're gonna use, as a signal of quality, we're gonna use ranking and brand. We're gonna buy high-ranked wines, and we're gonna buy from brands that we recognize and trust as having consistently good wines. We'll look at the dummies, and that's gonna represent those brand effects. But remember, there's 100 and some odd of them.
I have a question.
Yeah.
So what's that model saying as, if you don't know anything about wine, score doesn't matter, but as you start going higher and knowing more about wine, score matters? Is that?
I think so, yeah. Yeah, I mean, how many people knew there was a magazine dedicated to wine that ranks them, and, yeah, yeah, so not that many people know that. But you do know Napa, right? We're really looking at what's affecting people's purchasing behavior. What signals of quality are they using when they go buy? And for people that don't know much, they know the big signal of Napa. For people that do know a little bit about wine, they'll know that they'll use different signals like score and brand. Because we know that this still has brand in the model too. Now, if you're from Napa, the good news is people are willing to pay 100% more, twice as much for a bottle of wine from Napa relative to this equivalently ranked wine from Sonoma. That's the good news. The good news is those people are stupid. The bad news, actually, is those people are stupid. Not stupid. They don't know much about wine. So you can imagine how well this went over in Napa when I presented it. They didn't like this paper either. They didn't like my tasting room paper. They didn't like this one either. So,
It's anecdotal to support that. A friend of mine, she goes into small little wineries in Napa and kind of turns them around. And the last place that she was at, they weren't selling her wine, and she said, "You're underpriced." They raised their price by $15 and no problem.
awesome. That's always good.
They were like at 60 when they should have been at 75 for their cab. that
Yeah.
type of thing to be.
That is underpriced. I don't drink anything under $75. Yeah, that's good. That's not true. I drink Arbor Mist, that's what I drink here. Keep him keep him employed. How much does a bottle of Arbor Mist cost?
For you, I can get it to you for $2 a bottle.
$2 a bottle. But read, if I went to Safeway.
I think it's, I don't know, I think it's probably like $5, something like that. I mean, it's one of those tactile brands, that only it's clear salt bottle. Usually not, we don't sell a whole lot in California, to be honest with you. It's mostly out of state.
Nebraska. This was our initial question. Yes for low price cabs, no for higher price cabs. The Napa premium disappears. Consumers rely on brand and ratings as signals of quality rather than region. For Zinfandel, not really. There was some, there was some for higher price Zinfandels, but I think that's just an artifact of the data. Two lines are going to cross, and at some point in time, they're going to diverge, and so you can count that as the premium. So, but the results were really mixed to that. And this is really kind of the business nuts and bolts, the business aspect. What should I promote, right? Marketing dollars are scarce. So you gotta promote, you gotta spend your money where you're gonna get the biggest bang for your buck. If you're a low price cab, what do you brag about? And you're from Napa, you brag about being from Napa. People don't know school. If you're a higher price cab, you brag about your score. For Zinfandel, to me, it's all about brand. And again, somewhat suspect of these results, but because we just didn't see a whole lot of behavior. So I would say for both high price and low price Zins, it's more about brand than anything else.
What did you consider high price versus low price?
It's really score, but we're looking at.
Oh, okay,
Yeah.
it was the 91 versus
Yeah.
85,
For those of you that have binoculars, these are the dummy coefficients just ranked by size for each of the 4 segments. And would it surprise you that the biggest brand recognition, the biggest coefficient of brand, which is the biggest brand effect, is what? Opus One. Man, if you know wine, you know Opus One has an awesome brand. So no one's gonna be surprised by that. The other ones might, the other ones, when I presented this, there's always wine experts, so they know. BV, Schaefer, Etude. What's that?
Darius? This is the worst wine in America.
Is it?
My opinion.
Darius? What are they,
They're a gift shop that somehow surrounds the vineyard and has columns.
well, that's all of Napa.
Not the columns.
Yeah. Not all of Napa, but that's a big chunk of Napa.
Yeah, that's
Yeah, San Clemente, Artesa, we see these at the store. Big ass cab, how did you not like that? In Sonoma, Chalk Hill, you got, I like Chalk Hill, I like Dry Creek, I like all that area. For Zins, Napa Zins, Gurgich Hills. Yeah, I could barely read these and I'm right here. BV again. And then for Sonoma Zin, Martinelli, Rosenblum, was a big name is a big name in Zins. That's all they do, right? Rosenblum?
pretty much.
St. Francis, I buy St. Francis. I'll have a glass of St. Francis when I go home. Maybe in the car on the right. There's Ravenswood, Dry Creek, Kenwood, I drink Kenwood's in also. So yeah, no surprises here, Rally the Moon. Rodney Strong, and so on. Interesting, we had one, let's see, where is it? We had one bottle, we had one brand, I think it's Behringer. Yeah, I think it's Behringer that produces both a Napa cab and a Sonoma cab. I think they're Knights Valley cab. So we had the same brand that produced both, and that was an interesting case there. So where is it, Behringer? Behringer's got to be in both. I think. Is it up there? Where's my Behringer? And again, the omitted category, I just did this alphabetically. The omitted category was A, brand, right? With the race car name. Any questions? You guys want to go now, or do you want to actually go through the data and see how to do it?
Yeah.
Just giving you the options. I'm all about making you happy. So. That's my job. All right, let's do that. You know me, I'm never gonna. If there's something that says end slide.
Isn't it F4?
End slideshow. End slideshow. There it is. There we go. Still have to do that. Man, that's annoying. I guess since you can't see this, I can check the score on the game. Cincinnati 31, Cleveland 10. All right, we're back. Changes. I don't know why I have to do that every time. It's really annoying.
Oh, I thought you were telling us.
Don't stop doing that?
Yeah, like stop.
Yeah, I don't know. I didn't see it. I definitely would click it, so. Drives me nuts. All right, this is not us. So that's how you should test brands. Where are we, 10, 11? Yeah, that's us. Oops, do that every time too. All right, so here's our data set. Same stuff we've got. Price. We're not going to look at quantity. We're going to really look at, well, we saw the model. We're going to look at price and score. So, so let's see, although we're not going to do cases, let's just generate those real quick. And here's that first regression that we got, 6.9. Every 1 unit increase in score results in a 6.9% increase in price. And essentially what we're gonna do is just add to this model, right? We're just going to, and there's the graph, we're just gonna add dummies for region, dummies for varietal. We're gonna interact those things, and then we're gonna eventually add that score squared. So you know, at its core, remember this model, even with that big elaborate model, this, what is it, Sonoma County Zin's gonna boil down to that, right? When those Napa dummies zero out and when those cab dummies zero out, we'll be left with this model, just a more elaborate version of this. If we tab region, you can see we only have 2 regions. So the data set's already restricted, no lag. And it looks like it's a dummy. So 1 if you're Napa, and 0 if you're Sonoma. I did this, but you don't have to. You could have used region as a dummy, or we could rename region Napa. Either way, it'll come out the same. All right, so now we've got a Napa dummy. Let's tab varietal. Those aren't dummies, those are words. So we gotta generate dummies for those.
For cabins and.
For 1, yeah. So we just called it cab. We tab cab. It's 0, 1 if it's cab, 0 if it's, in this case, not, which is Zin. I labeled these. I think these are already created. Yeah. This is nice in that, right, when we tabbed cab, we got the 0, 1, but if you put a label over it, it's still the 0, 1. There we go. Now let's tab that. It'll show up in your regressions as Zin and cab, as opposed to 0, 1. All right, let's start with that simple model. Here's all our interactions. Napa times cab, Napa times score, cab times score, Napa times cab times score. That's the model we were looking at. You run the regression. Right, so here's our results. And then we do the house cleaning. We put for this case, right, if you're not a Napa wine and if you're not a cab, then if I'm not a Napa and I'm not a cab, then if I'm not a Napa wine and I'm not a cab, then all of these zero out, right? And if I'm not a Napa cab, if I'm not from Napa and I'm not a cab, what am I? Sonoma Zin, exactly. So that coefficient, 0.035, is the ratings effect for Sonoma Zin. And then we can do all the math like we did in the PowerPoint. We calculate ratings effect for Napa Zin, and so on and so on and so on. do all the predictions. So, before predictions, because we have 4 different wines. We got Napa, Cab, Sonoma Cab, Napa Zin, Sonoma Zin. And we can generate a nice, there's your graph. It's just like the PowerPoint. Should. All right, that's easy enough. Doing some of the calculations, we can use margins. So we use margins? So we can just say, instead of doing display, all that stuff, which is fine also, we can just say margins at Napa equals 1, Cab equals 0, Napa Cab equals 0, score equals 85, Napa score 85, Cab score 0. So what is this? This is it's a Napa, it's a Napa Zin, exactly. It's a Napa Zin at a score of 85. So the log price of a Napa Zin at a score of 85 is 2.83. Again, has absolutely no interpretation. No useful interpretation. Same thing, but I switched Napa off. So this is a Sonoma Zin at a score of 85, has a log price of 5. And if you take the difference, it represents the premium. Again, this is somewhat awkward if you go back to the graph. We're not really that comfortable with these results. It's really the cab results that make a lot more sense. So let's do these. Napa Cab. Yeah, those are all our ones. Napa Cab, so it's Napa, it's a cab. Log price is, where'd it go? Oh, 3.2. Sonoma Cab, 2.9. You take the difference, and we get it's a little bit different, but it's 39%. I think we got 33% in paper. We did a few other things. So in this model, and this is that first iteration of the model, consumers are willing to pay 39% more for a Napa Cab over an equivalently ranked at 85, score of 85, over an equivalently ranked cab from Sonoma. All right. Then we did what? What did we add to the model next? Brands. Where is brand? Brand. Oops. Well, we know how many brands there are. There's a lot. We need a dummy variable for each one of these. You can't use IDOT because these are words. IDOT only works with numbers. Works with months because month is 1 through 12. and it created those 12 dummies, 11 dummies.
Do we number them?
Could we number them? Yes, we could. There is a way to recode these as numbers, but yeah. That's a lot of dummies. How long would that take to generate all those dummies? A long time? What if I told you there was a quick way to do it? How much would you be willing to pay for that?
How much Arbor Mist can you drink?
A bottle of Arbor Mist at least? A bottle of Arbor Mist. Yeah, so there's a way to do it. So we just tabbed this, right? We tabbed it and it's gonna list all the values and it tells you how many observations for those. Lots of Clos du Bois. I don't see Arbor Mist in here, by the way. Bummer. Remember, the wine has to be grained. And then it has to be in the, I'm sure Arbor Mist is in the scan data. It's just not in the wine speculator rankings. So here's our new command. You're gonna love it though. It's basically the same as tab, but it's called tabgen. And what it'll do is in one command, it'll construct all 100 and whatever dummies there are. Awesome. So I'm gonna read tab, I'm gonna put comma, gen, and then I'm just gonna call this generate 100 and some odd dummies with the name brand on it. And for each one, it's gonna add like brand 1, brand 2, brand 3, and so on. So as you can see, Andretti's first, Angelina's second, Artesa, Artisan, blah, 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 BB. Now, scroll down to the data set. Brand 1. And we can't do this one. Brand 1 is a dummy for Andretti. So if I tab brand 1, it's going to be a 0-1 dummy. And it tells you what it's for. Very cool. Very cool. So it saved our carpals from tunneling. And that's bad. Well, saving us is good. Now what we can do is we can go to our previous model. And we've got to add all those dummies. So how many dummies are there? 107. So we need to include what? 106. So we don't even have to type all 106 of them. We just have to say brand 2 through grabbed brand 106. That does it for us. Now, remember, it's going to be a big regression because it's going to have 106 dummies in it. I'm sorry, 105 dummies in it. But we don't really worry about the brand coefficients, why I put it at the end. Because our Napa premium and all that stuff will come from the other stuff.
Shouldn't it be brand 2 through 107?
7, right?
Was it 7?
Because you said you're only getting 106, so you're skipping one, but you're skipping one on the last one, right?
Yeah.
Yeah.
I've never been good at math. Again, ignore all the brand stuff. But those are our coefficients that we want to, that we're going to pull the brand effects from. And lots of lots of dummies. And notice that the dummies are mostly significant, except for a couple. I don't know what brand 106 is, but what would you say about the value of brand? How would you interpret brand, well, let's just say brand 107, well, which is significant. Dummies are always interpreted as what? Differences, right? So, brand 107, whatever it is, well, white something, it's like, or something with the WH. Guess we can look at that. White oak? No, white. Whitehall Lane Winery, and then White Oak Vineyard. So 107 is. So basically this is the value of brand 107 has a coefficient of 0.73. These are logs, so we can treat that as a percent. 0.73% increase in the value of brand 107. Is that right? So brands are always a difference, but it's a difference from what?
First brand.
From the default, which is Andretti. So it's how much more value brand 107 is, which was White Lane. How much more value White Lane is, the brand White Lane is, relative to Andretti. And it's got a positive and significant coefficient. Now, for White Oak, its value is statistically insignificant, which means its brand value isn't statistically different from what? From Andretti, exactly. So it has about the same brand recognition as Andretti does. And so on and so on and so on. And again, what I did is I just ordered these by, in the PowerPoint, I just ordered them by magnitude so we can see which ones were biggest and which ones were smallest. But this is measuring the value of a brand. And the fact that they're significant means that consumers are taking brand into account when they're making their decisions. Because that's really what we're trying to measure. We're trying to measure what factors affect how much consumers are willing to pay for a wine. Our dependent variable is price. What factors affect how much consumers are willing to pay for a wine? And brand is statistically significant for most of them. And again, this doesn't mean it doesn't have a brand effect. It just means that it doesn't have a brand effect that's any more valuable than that of Andretti. And the negative ones would say that they have less of a brand recognition. You've got negative in there, right? Nope.
Yeah, the middle, brand 90.
Oh,
no.
There's gotta be some. Yeah, there's one. So the fact that they're all positive, almost all positive, tells you what?
Andretti doesn't have a good brand.
Exactly. Andretti doesn't have much of a brand effect. Compared to Andretti, almost everything has a better brand, has more brand recognition. Which is strange given the name. I mean, the whole point of naming a winery after yourself is what? You've got good brand recognition. But apparently, among wine consumers, they don't value the name Andretti as much as race car drivers, for example. People that go to race car races probably drink more
Budweiser?
Arbor Mist or Budweiser than they do Napa Cabs or Zins or Bud, or probably Coors, right? So. are you really leveraging the value of your name in the wine industry? And again, I'm gonna be the last one. Is Mario Andretti still alive, by the way? Do you know? He's gotta be pretty old, right? There was one. But yeah, the leveraging your name into the wine industry didn't seem to carry much. For example, if I was the #1 tractor pull driver, I'm a legend at the tractor pulls. I go there and I'm the man. Can I leverage that to make my own wine? Probably not, right? Those two circles, wine drinkers and tractor pull attendees, are probably not overlapping very much. So, really, like I said, this is how we measure brands. Really interesting results. Just the fact that they're mostly positive is and again, I picked Andretti because it started with an A, it was the first one. It's the easiest to leave out when you're saying brand 1 through 107. Just start with 2. If I was to leave out Opus 1, what would all the coefficients be? Because relative to Opus 1, they probably have less than brand. Would it change the model at all? No. It just does what?
Makes everything look bigger.
Changes the base. We're all supposed to do the shot when I say it changes the base. Drinking game, we bet. All right, so let's go up and essentially we're gonna do the same thing we did in the previous. We're gonna calculate the ratings effect and our Napa premium the same way. What we're gonna do is essentially ignore the brands, because there's 106 of them, so we're going to ignore it. So let's evaluate. We did our prediction. Did we do our prediction? Did we do this here? Not yet. So which we probably already grabbed this. No, what happened? Oops. Do that. Ready? Highlight. Just a piece of it. Econometrics is really tough. All right, so there's our model with brand effects. And again, the vertical distance, we can calculate those right now. Again, using margins. Reuse the same margins command. All right, we've got, score at 85, we're evaluating at 85 again. Napa is 1, so that's Napa. Cab is 0, so it's a Napa Zin. And then below that, we have non-Napa, non-cab, so it's the Sonoma Zin. Log price 2.4, log price 1.2. Take the difference, and that gives us our premium. Again, this is the Zin. More less interesting results are with the cab. All right, so for the cab, we can see again up here, Napa cab, Napa cab 85, and the interactions, not Napa cab, and the log price 3.8, log price 2.5, take the difference, and that's 39. Is that right? Isn't that what we got before? I think so, right? This is- oops.
Yeah, this one.
No, there's our regression, it's our post regression, so that's it. So let's. Margins, display. That's gonna be it. Why is it not recognizing thing two? Frame two has it. Oh, it's capitalized. How would I capitalize that? Alright. Should get that. Should be able to. These are for cabs. Is this the same thing? Yeah, there we go. Oh, I know what I did wrong. Christ. I copy and pasted my display, but it's the same values, so. All right, this is our Napa Premium, which is about 130%. It's a little bit different than what's in the paper, but the models are a little bit different. I left out some of the promotional stuff to make it easier. So for consumers are willing to pay 130% more for a Napa cab over an equivalently ranked cab from Sonoma. All right. And adding the nonlinear term is as easy as it sounds. So, generate scores. Score 2 equals score squared. And anything that had score, we're now going to add a score squared. So we had Napa score, so we're going to have Napa scored squared. We had the cab score, so we're going to have cab scored score squared. And then we had Napa cab score, so we're going to have Napa cab score squared. Just multiply out. We add these 3 new variables to the model. That'll give us our curvature. It'll give us main results are up here. So we've got all our non-linear terms here. And as long as we can shrink everything down, we're going to do the housekeeping, cleaning, we should be able to get our Napa premium as well as our score ratings effect. So once again, no, I should do this first. You're gonna get a weird looking graph. Once you put in the dummies, you're gonna get weird graphs. Because you have the dummy variables in it. All right, so this is for Napa Cab. And if you look at so we're still looking at 85. 85 squared is apparently 7,225. You should be able to do this. Thank you. So instead of doing the math, let's see if this works. 85 squared. Nope, you didn't recognize it.
Yeah. I guess that's why I did it first.
So you gotta do the math. If you're going to use, margin, it's not gonna recognize, you trying to square. Bummer. But that's fine, that's why you have this data. All right, that's log price. Early log price. We got this is, what is this? Is this Napa or Sonoma? Sonoma. So, at a score of 85 with our nonlinear model, the Napa premium is about 112%. The consumer's willing to pay 112% more for a Napa wine over a equivalently ranked Sonoma wine. But with the nonlinearity, that's going to change, so we can change that. There's 80, and there's 90. Before we do the math, what can you tell me about the premium? What are those log prices doing? Getting closer together. So the premium's gonna be relatively small. We got 3.8 and 3.35. So there's gonna be a premium, but we know it's reduced significantly.
This is with the higher score.
This is at 90, yeah.
Could you plug in any score? Could you plug in like 92?
Yeah, absolutely. This is still 48%. I mean, it's still a sizable premium, but it's gonna get smaller and smaller as you move up, as you move up the, price points. Questions?
What is your no estimate?
Oh, good, good, good eye. Just need to check.
Where is that?
It's at the very end of my margins.
Oh,
Yeah. What happens is in the calculations for this, the way Stated actually does the math, it checks itself to make sure it's doing it right. And sometimes it will trip itself up and it'll stop, it won't work. So if I don't do that, what's the error go? So we saw that thing pop up pretty quick. No, this one it didn't matter, but obviously I put it there because one of them wasn't gonna work. And it's really, it's not gonna change anything, but for one of these, for whatever reason, it's, I forgot the technical reason. It won't work without them. So this just kind of turns off that check.
just for the margins community, or in this?
Just for these margin commands. The reason this works as fast as it does is this thing called the delta method. And it's just it's a shortcut method of approximating the standard error. You're gonna get almost the exact same standard error, but it just works faster. And that's where it trips it up, using the delta method. It's a mathematical. It uses a Taylor approximation, if you know what that is. The graphs for these are gonna be messy. Remember, the dummy variables are shifters, so it's shifting that line all over the place, which is why we didn't graph these. You graph them, you'll get a picture of what you're getting, but essentially, remember the dummy variables are shifters, so it's going to kind of be fuzzy. Like that. And like that. Now what I did in the paper was kind of look at an average for those curves, but for you guys, that's fine. Really the important part is being able to interpret the regressions, come up with those coefficients, come up with those slopes, and kind of answer the question. This seems like a really important question. What are consumers using to make their purchasing decisions? We've got three signals. We've got score, we've got brand, and we've got ratings. And we've got region, I'm sorry, we've got four signals. Score, brand, ratings, region. So we got four signals of quality. Which signals are consumers using to purchase the wine, to make their purchases? And we see at the low end, it's regional brand. At the high end, it's score and brand, and not so much region. So we're really getting an insight into how consumers are making their purchasing decisions. And I think that's important. That's an extremely powerful thing to know is what is affecting consumers' behavior. At least it seems powerful to me. It seems like something you might want to know. irrespective of your product. Some of the literature for this was for cars, which makes sense, right? You've got, or any product, you've got consumer reports that rank stuff, rates stuff. This is just our consumer reports for one. Any questions? Is this much of a stretch? We didn't, we really added one thing, right, the nonlinear. We've done dummies, we've done interactions, now we've got nonlinears. What's that? One extra step. And it's easy. Just generate them.